So same thing when you go over here, because if you FOILed that out, for example, yours, people were thinking it was just 8 or 2 and 4. No. Same thing would happen on 4. You forgot the easiest thing. Oops. When you're finding zeros for something like that, again, what's your first rule of factoring? GCF. Some of you guys did multiply the 2 and the negative 30 and worked your way through it. It was fine. You got to the right answer, but it was a lot more difficult. When you take out a GCF of 2, you have x squared plus 2x minus 15 plus 5 minus 3, negative 5, and 3. You're done. They should be that quick. If you're going to factor something, you should be able to attack and factor without hesitation. The 2 above it, identifying parts. It was either when you went back and substituted in, you missed a negative, or you miswrote it, or you forgot completely how to find the axis of symmetry. When you have vertex form, remember, the vertex form gives you the h and the k. The h is the x equals h is the vertical line for the axis of symmetry. And then it's just, if you were in the other forms, it's just a matter of getting the midpoint and substituting that. It was just some arithmetic errors more often than not in those. As you get to the back page, the first one was usually okay. A lot of times people forgot plus minuses because you took the square root. There was the I on that one. There was a plus minus also on number 6. The mistake that I saw sometimes on 6 was that people forgot that when you move a positive number, you have to subtract it. So that was just kind of a dumb mistake. But then on number 7 mirrored one of your homework problems almost verbatim. Number 7 mirrored a homework problem basically almost identically. Multiply everything here by 10. Get rid of the fractions. I think the one we had in our homework was a 2, 5, and a 10. This one's just 5s and 10s. So if you multiply everything by 10, excuse me, you get 10 over 5, which is 2. So this becomes 4, x minus 2, quantity squared. 10 over 10 is 1. 10 over 5 is 2. And there you go. You cannot distribute into parentheses that are being squared. Too many of you guys try to do that. That is not mathematically correct, nor does it make any sense. You do not FOIL this stuff out. You work backwards when you have junk squared. Okay? Add 1, divide by 4, you get x minus 2, quantity squared. It's 7 over 4. This one I made sure that you would, when you took a square root, your denominator would have to be rationalized. Guess what's the square root of 4? 2. We wind up with x minus 2 equals plus or minus root 7 over 2. And then all you have to do is add 2. And you were done. Okay. Then next one, same basic idea, but you did have to rationalize. Negative 2, excuse me, negative 2, x minus 1, plus 3, 6, so, I'm sorry, excuse me. Again, you cannot distribute in. It's not mathematically correct. Subtract 3 divided by negative 2. You get x minus 1, quantity squared equals negative 3 halves. Square root both sides. You get x minus 1 equals plus or minus square root of negative 3 divided by the square root of 2. Whenever you have a fraction, I cannot recommend this highly enough. Make square roots on both sides. Sometimes when you guys write it and it's not large enough, and you forget that the denominator has a square root in it as well. Make sure you put it in both pieces. Then you remember, you remember to rationalize. So when you rationalize this, you get root 2 over root 2. So x will equal 1 plus or minus I root 6 over 2. And that's what that would look like. again, anytime I give you stuff without calculator, I want to make sure that roots, solutions, things like that are going to be easier things to find. You shouldn't have to worry about forgetting how to simplify. What was the one we've been having a lot of? Was it 171? Square root of 171. So we've had the square root of 171 in the past couple of homeworks, I've noticed. So it's just one of those weird ones. And then the last four, of all of them, 9 was the one that was missed the most, which was really weird. That's I plus 4 plus the square root of negative 4. What's the square root of negative 4? 2i. What's 2i plus I? Done. There's no plus or minus there. A lot of you guys put plus minus in the middle of it. You only do plus minus when you go over an equal sign. You only go plus minus when you go over an equal sign. And then the last one's number 12, or sorry, number 10. If you screwed that one up, you forgot that it was subtraction. Remember when I said, hey, watch the signs in between? Some of you will accidentally FOIL it. You accidentally FOILed it. And then sometimes you guys forgot that I squared was negative 1. But also, I don't know if I mentioned this to you. Will you ever have to do that? Not having a good computer. Excuse me. Let's try this again. Stop updating me. Hey, look at number 11. Watch what I do. Alpha y equals 2 plus 3. Whoa. Alpha y equals 2 plus 3. Oh, look at that. There's an I button. Will I ever have you do that one by hand? Nope. Button for it. It does it for you. All in all, that one, that's kind of what we're looking at. I'm sorry, excuse me. The other stuff that obviously that we've been working through is, remember when we're talking about the graphing, you had your ax squared plus bx plus c. Your axis of symmetry, I know we went over this before, was x equals the opposite of b over 2a. Your vertex then was at that value, comma y, whatever you substitute in for. You had vertex form. Where h and k are the vertex. X equals h is the axis of symmetry. And then the last one was the intercept form, and that's when you just had to get the midpoint to work your way out. And you find the midpoint of the zeros to get the axis of symmetry. Now, we used that intercept form a lot when we dealt with the word problems. Remember how we did cost break ones? One thing went up, the other went down. That's a super common style quadratic one. In fact, in the math team tests that we've had for the past, I've been doing it for 10 years or so, there's a senior level test called optimization. Optimization means you're trying to optimize or maximize or minimize or whatever, some levels like. And it's basically finding maximums, finding minimums. They do quadratic maximums on that test pretty regularly, and it just stems from cost, sales figure, so much price goes up, so many sales figures go down, and understanding what the X values mean. So if you go back into your, remember that big old packet problem that we had not too long ago?
No.
What's that? And I know that we've done pretty much all of them. But what I want to sometimes I just want to do in class. Did you do the banana problem? I don't think we did. So on the very back page of this one, there was a banana problem. The grocery store sells 300 pounds of bananas a day when they're priced at 45 cents per pound. The produce manager observes that for each 5-cent decrease in price per pound of bananas, an additional 50 pounds of bananas will be sold. It's a whole lot of bananas. The sales are going bananas. Your word impressed. Relations in there. Again, when you're dealing with something like this, you have 300 pounds at what price? 45 cents. Okay. You sell 300 pounds at 45 cents. It says that for every 5-cent decrease in price, an additional 50 pounds are sold. So if I'm dealing with this in terms of, if I'm dealing with this one in terms of, if I'm dealing with this in terms of decimals for cents, what's 5 cents look like? What? So, so if I decrease this 0.05 times, I have an increase of 50 per each time. So what I want you guys to remember is that this x value is like the number of times the price changes. I'm trying to think of an easy way to say it. If you think of it that way, it's the number of times the price changes. If it changes twice, that means the price went down 10 cents. If it changes 3 times, the price goes down 15 cents, and so on and so on. So if you change the price 3 times, that means you're going to, if you decrease the price 3 times, you increase the poundage 3 times. So if it goes down 15 cents, the poundage goes up 150. See how that works? That's what that X represents, the number of times something changes. Not so much price change or I just things change. Think of it that way because they're different to each other. Now, when we did this one in class, we found that it was easier to just put them together, find the zeros, get the axis of symmetry. Because if you FOIL this out, you're going to wind up with a negative x squared. Everybody see that? That's why it's a maximum. That's why I was saying all along, is it a minimum, is it a maximum by looking at the first value there. So what we do is, we just draw a quick little line and plot the 2 zeros. When I find the zeros here, basically I'm going to take 45 divided by, or 0.45 divided by 0.05, which is 45 divided by 5. If I do that, I'm going to get 15. Okay with that? And I know it's going to be a positive 15 because if I set this equal to 0, I would move that over. I'm going to get a positive 0.05x equals 45. I do the same thing on the other side. I'm going to have a negative value. Okay, I'll have a negative value. So what is 300 divided by negative 50? What's 30 divided by 5? 6. So my other side would be at negative 6. Oops. Yes, sir. 45 divided by 5. That would be 9. I was thinking of 15 cents of the difference there. I'm sorry. Have I mentioned that I can't hear very well? My head is throbbing. The head cold is awful. Don't coach baseball in the rain 2 days in a row. It's not good for you. It's going to be great. Because guess what's going to happen Friday night and Saturday night? It's also going to rain. Yes, ma'am. You'll have your calculator. So you can just, because all I'm doing is this. That's all I'm doing. That's what it's looking like. This would have to be on a calculator. I'm not going to make you do this without. The quiz stuff would be what I would put in it on. And it wouldn't be anything, guys, these are good questions. And it wouldn't be anything that I wouldn't make you complete this curve. So to find the halfway point, what's -6 plus 9? Be -3, then we have to take half of it. Remember, we're adding them together. We're finding the midpoint. So the halfway point would be, what, that 1.5? That means if I change the price 1.5 times, I maximize the amount of poundage of bananas I'm going to sell. -6 plus 9 divided by 2. Find the midpoint. Excuse me. So then I know that if I go to my calculator, I do 300, I forgot what it was, plus 50 times 1.5 gives me 375. I get 375 pounds of bananas at a price of 0.45 minus 0.05 times, oops, at 37.5 cents. Okay, it's 37.5 cents. Do they charge 37.5 cents for things? No, but they charge you $1.99.9 for gas. But would you, if you said 37.5, would I be okay with that? Because at 38 cents, it wouldn't be the right price. It's a little, because you can't, whatever. So if you put 38 cents, I wouldn't yell at you because it rounds out through, but I would say at 37.5. Because if you think about it, if you buy 2 pounds, that decimal goes away. It's just going to round it at the cash register. So that's where it gets a little weird. That's why a lot of times cash register, that's why they round things through. So another thing that you can ask on something like this is, I could ask you, at what price do you sell so many pounds? So what you would do is that's when you would use your table. Now, we know what our function was. It was 300 plus 50x, and it was 0.45 minus 0.05x. I know that's what my function was. That's what we wrote out to begin with. If I look at my table, this tells me the number of times that if I change the prices. If I change the price twice, I'll sell, excuse me. If I change the price twice, if I use that for my X value, so if I decrease it 2 times, I would sell a total, my overall profit would be $140. You got to remember what that Y value is equal. The Y value here is how much money you're making, not, back and forth. So if I ask you, at what price would you make $125? Then you would look in your table, well, I make $125 when I change the price 4 times, which means that value of X gets multiplied, or that value of X is 4. So what's 4, how much money is 4 nickels? 20 cents. So I'd have to decrease my price by 20 cents, and then I would make $125. See where I'm going with that? That's what those values of X represent. I could ask the same thing with poundage. Obviously, the poundage part isn't in here. but but the prices are. If I do the same idea and say, hey, how many pounds would I have to sell, or how many pounds would I sell if I make $110? Well, I've looked at my table to where it equals 110, and I know that that's the multiplier of X, 5. So I would look at my formula, it was 300 plus 50 times 5. So that's what, 550? Is that right? So I would, to make $110, I could sell 550 pounds. But remember, what goes up must come down. So not only could I increase price, or I'm sorry, I'm decreasing price. What happens if I increase the price? Could I do the same thing? Because of the travel of goods. So just be careful on how it's and what you're reading. More often than not, we're dealing with a positive value, trying not to trick you to looking at, oh, you said you can do it the other way. More often than not, you're looking at, you don't want to raise prices to sell less, to sell more. You want to lower prices to sell more. The other style that we've been doing, we're like, just, remember like the cannonball one? Just understanding what the graph represented. I'm not trying to skip over anything, but remember when we did the border uniform width, those were pretty simple. They're just adding or subtracting the 2x and then it's shaded area problem. But yeah, what was it? Bless you. I don't remember what page it was on. They're like our rabbit jumping, or sorry, the woodland jumping house. What's the candle one? Oh, there it is. It's on the first page. Sorry. Yeah, remembering what that means when you have when they give you like a and it tells you where x is the horizontal distance, y is the vertical distance. So that means when it starts, it goes up, it comes down. Remembering that sometimes in the instructions they're talking about not horizontal and vertical distance, they might be talking about a vertical distance over time. How many seconds does something elapse? Okay, so you just have to make sure you read what they're talking about in terms of their axes. I think what else I can give you. That sheet that I gave you last night with some of the extra, what do you call it? Algebra problems, solving for axes, things like that. Was there anything in particular? I don't know if you saw it on that. I posted this one yesterday towards the end of the day, and I put all the answers on it. That on the last page. Just remember on the tutor sheets when I put the answers get posted, they'll split up fractions a lot. So I'm not yelling if you don't split up fractions. I want you to simplify them, but you don't have to split them apart. But was there anything on there you wanted to look at, or was it enough? Yes, sir. Sure. Can you read me the problem real fast? Oh, I'm sorry. What was it? Equals 6. And the question is, find the discriminant. Tell how many and of what type of solutions you have. Okay. So when you're trying to find the discriminant to tell how many and what type of solutions you have, that's when you turn off our phones. That's when you have to set aside equal to 0. So if I subtract the 6 over, I'm just going to get 1. You okay with that? So remember, your discriminant is just b squared minus 4ac. No roots, no nothing. The discriminant tells you one of 3 things. It's either positive, negative, or 0. If it's positive, you have 2 real solutions. If it's negative, you have 2 imaginary solutions. If it's 0, you have 1 real solution. So you just put a substitute in the blanks. We get 2 squared minus 4 times 10 times 1. Well, I'm going to get 4 subtract 40, which gives me a discriminant value of negative 36, which means I have two imaginary solutions. Does that make sense? That's what discriminant goes for, right? That's what that goes for. Yes, sir. Yes, sir. I think I would. Oh, complete the square. This is 16, guys. I'm right. I'm just using x's. And all I did is I just moved the c value right away as I wrote it down. Are we okay with that? Completing the square first term. Yes, sir. Oh, I read it wrong. I'm sorry. So if I add it, then it would be 10. You know why? Because I put the plus sign there because I knew I was going to have to add something, and I just thought that's what it was. What happens? I don't have it in front of me. So I moved C right away. Now I go through the process. First thing is to take half of B. Half of negative 9 is negative 9 over 2. That will just drop into my parentheses, and I get x minus 9 over 2. When I square that, I get 81 over 4. Okay, be all right with that? So now, I need to combine the 10 and the 81 over 4, which means we're going to rewrite 10 in terms of 4. 40 over 4. Okay with that? Well, how convenient is that? Yeah. It's a nice one. I love it when a plan comes together. So now, square root both sides. Excuse me. I get x minus 9 halves equals plus or minus 11 over 2, which gives me an answer of x equals 9 halves plus or minus 11 over 2. And like I said in the past, you do not have to get your two solutions, even though those are pretty quick and easy. Okay. Does that help on that? So it looked like it was going to be awful, but it wasn't. And here we go. I could, or I could say just solve. And I can leave it up to you, because remember we spent those couple days of just kind of figuring out what's the best way to go. I just wanted you to practice this, because you never know what happens. I know. We haven't done that. I like to do when I talk about graphing stuff, I like to be able to identify parts, like we did with the quiz. I like doing those instead, because it takes less time. That's all. 15? So we're complete the square. Okay. Move the 67, and then you'll have to divide everything by 9. So you get negative 3's, right? So that's 3, 23. So half of 20 over 9 is 10 over 9. Square it, excuse me, you get 100 over 81. At that point, you have a calculator. You have to try to do that. That's all. Bless you.
I get negative 521 over 81. Sounds like great numbers. Square root it. We get x plus 10/9 equals plus or minus I root 521 over 9. I know that's going to happen. And if you have the calculator, remember how to simplify the root? Y equals 521 divided by x squared. And a whole lot of nothing. And you're done. I'd get 521 divided by x squared and look at your table. Now, here's the deal. That's god awful ugly looking of a fraction. I've made it a point to make sure that anytime you have to take a square root, it's something you're going to do. Obviously, if you have the calculator, what I'm doing here with the table, something you might want to remember in case. I'm taking 521 divided by x squared. And by doing that, it's looking to see if any perfect squares go into 521. So it's checking what's 521 divided by 1 squared? 521. What's 521 divided by 2 squared? Something, and so on and so on and so on. There are no perfect squares in 521, which means, you know, yes, I'm always mad. Leave your answers in square root radical forms. She gave me a side eye over there too. Just use. That's why you use simplified radical form. Yes, sir.
For the homework,
Yeah.
last two problems, like I did the matrix thing, but on the back of the book, like the answers were much different than what the matrix thing.
Really? Let me grab my book and we'll take a look at it. Oh yeah, I want to remind you guys of a little shortcut on that one, in case you didn't figure it out. Thank you for bringing that back up. When you're doing those matrices, which were the two problems I forgot what numbers they were? 29 and 31? Okay. So if I'm looking at 29 real quick, guys, it has the ordered pairs of 1, 2, 3, 4, 6, negative 8. What I want you guys to remember when you're building your matrices, you're going to have a 3 by 3 inverse to the column. And also remember it's an ax squared plus bx plus c equals y. So this is going to equal, bless you, you're trying to figure out what a, b, and c are. Now, I don't know if you picked up on this yesterday, but the coefficient matrices was always whatever x squared was for the first column, whatever x was for the second column, and 1 for the third column. The last matrix was always your y value. So 1 squared is 1, 1, 1, 2, 9, 3, 1, 4, 36, 6, 1, negative 8. Now, you could get messed up real quick if you hit a negative button instead, or a minus button instead of negative, or you just accidentally hit the wrong thing. So alpha zoom 1, 1, 1, 9, 3, 1, 6, 6, 1, inverse alpha. 2, 4, negative 8. I get negative 1, 5, negative 2.
You didn't do the inverse. Gotta do the inverse. That's the idea here, guys. If you're not getting that, you have to remember that you're inversing it, because what you're doing, what I want you to think of is, how do you undo multiplying? You have to multiply by the reciprocal or use the inverse. Right? That's where that comes from. All right. What else we got? Anything good? Hi, Bella. Thank you for asking. When you get your answers, you get the answers of A, B, and C that was -1, 5, -2. -1, 5, -2. The question was, write the equation of the quadratic function that contains those points. So writing the equation then would entail -1x squared plus 5x minus 2 equals y. And that would be your final answer. Yes, ma'am. Oh, 2 or 3, but you can easily ask multiple parts of it. Like I was just saying, what price could you sell this for? How high up does something go? How long is something in the air? Things like that. So you can ask different parts of the questions to get there. But yeah, there's only 2 or 3 of them. I space things out pretty good. And you should have plenty of time. Try not to ever overwrite it. That's fine. What else we got? Senor. Yeah, but. Okay. The vertex formula you did yesterday. What happens is you have a vertex and a point. If you have a vertex and a point. Let's see. What did you shoot for last night? What number was it? 11 and 12, I think. 12 and 14. All right. I'll do number 12. 12. Oh, was it? One of the ones we did. Oh, really? Nice. All right. Well, then I'll do 14 because I don't think that was in the notes. I'll do the vertex at 1, -10, and the point is at -3 and 54. Okay. So first thing you want to do when you have a point and a vertex, write out vertex form. Vertex form is y equals a x minus h quantity squared plus k. And what I want you to think of is that you have 5 variables in that form. Y, a, x, h, and k. There are 5 of them. You go solve for the day. So when you have your vertex and your point, what I want you to do is label it. H, K, X, Y. Substitute in. Direct substitution from here on out. You know that 54 has to equal A times -3 minus 1 quantity squared minus 10. What's -3 minus 1? Square it, you get 16. So I have 54 equals 16a minus 10. Add the 10. I get 64 is 16a. Divide it out, I believe you get 4. So now you've identified what the a value is. And when you go back to the vertex form, all you need to reuse is your h and k. So when I reuse my h and the k there, for y equals a x minus h quantity squared plus k, it would wind up being y equals 4 x minus 1 quantity squared minus 10. What you're doing for all forms like that, Jackson, you're for that one and the intercept, you've got 5 variables, you've got 4 final bit. Is that a little bit clearer? Label. Okay. Label. Don't forget one other thing real fast before you forget. Zeros are created by terms. Terms create zeros. If you have a 0 at 3, what's your term? X minus 3. If you have a 0 at -7, what's your term?
x plus 7. That's just one of the wrong with that. Some people tend to forget. What's up? I don't have maps. You just sign out. Excuse me. Yes, sir. What do you have?